Good day, ma'am. Good day, classmates. Today, I will be discussing about a short lecture video of graph coloring for graph theory and applications Math131-G1. Contents. This presentation provides the following contents, and these are graph coloring, chromatic number and its types, vertex and edge coloring of a graph, and application of graph coloring to real-life scenario. For part 1, what is graph coloring? Graph coloring is an assignment of colors or any distinct marks to the vertices of graph in such a way that adjacent vertices have different colors. So in simplest definition of graph coloring is to assign any colors to any vertices so that the neighboring vertices would not have the same colors. For example of graph coloring, so assigning the 6 vertices and different colors such as red, yellow, blue, orange, pink, and green. So in this graph, we are showing a properly colored graph. The given graph contains some points, which are described as follows. So the same color cannot be used to color the 2 adjacent vertices. Hence, we can call it as a properly colored graph. For part 2, what is chromatic number? The chromatic number of graph is the smallest numbers of colors with which it can be colored. So when we see chromatic number in a graph, so we can say that it is the smallest or the minimum number of colors given in a vertices. So considering the example earlier, the cycle 6, so the chromatic number is 6. It is because there are 6 different colors and it has the minimum number of colors as properly colored graph. So since this is different, and different, so the chromatic number for this graph is 6. So there are types of chromatic number of graphs. There are various types of chromatic number of graphs which are described as follows. The cycle graph, planar graph, complete graph, bipartite graph, and the tree graph. Cycle graphs. A graph will be known as a cycle graph if it contains n edges and n vertices, where n is greater than or equal to 3, which form a cycle of length n. There can be only 2 or 3 number of degrees of all the vertices in the cycle graph. To determine the chromatic number of cycle graphs, you need to follow the basic properties. So the chromatic number in a cycle graph will be 2 if the number of vertices in that graph is even. Otherwise, the chromatic number in a cycle graph will be 3 if the number of vertices in that graph is odd. For example of cycle graphs. In example 1, in this following graph, determine the chromatic number. In the given graph, this is a cycle 3. So there are 3 different colors for 3 vertices. So blue, red, yellow, 1, 2, 3. And none of the adjacent vertices are colored with the same color. So they are all different colors. In this graph, the number of vertices is odd. So given this graph is ang number man sa vertices is bungkig. So thus we can say that the chromatic number is equal to 3. Another example of a cycle graph. So considering this graph is a cycle 5, but you can see that there are only 4 colors. There are 2 blue. So considering that, it will only be 1 color. In this given graph, there are 4 different colors for 5 vertices. So, and 2 adjacent vertices are colored with the same color blue. As you can see, blue and blue are adjacent. So this graph is not a cycle graph and does not contain a chromatic number. Planar graphs. A graph will be known as a planar graph if it is drawn in a plane. The edges of the planar graph must not cross each other. So, the basic properties considering the chromatic number of these graphs, in a planar graph, the chromatic number must be less than or equal to 4. The planar graph can also be shown by all the given cycle graphs example number 2. So example of planar graphs. So considering all these example graphs for the planar graph. So for this first graph, there are 3 different colors for 3 vertices, 1, 2, 3, and none of the edges of this graph cross each other. So the chromatic number for this graph is equal to 3. Here, the chromatic number is less than 4, so this graph is a planar graph. Another example, there are two different colors for 4 vertices, and none of the edges of this graph cross each other. So, ang chromatic number niya is equal to 2, and it is less than 4. So this graph is a planar graph. For the third example of cycle 5, this cycle 5 has 5 different colors for 5 vertices, and none of the edges of this graph cross each other. So the chromatic is equal to 5, but 5 is greater than 4, so this graph is not an example of planar graph. Complete graphs. A graph will be known as a complete graph if only one edge is used to join every 2 distinct vertices. Every vertex in a complete graph is connected with every other vertex. And this graph, every vertex will be colored with different color. That means in the complete graph, 2 vertices do not contain the same color. So, to determine the chromatic number for this graph, in a complete graph, the chromatic number will be equal to the number of vertices in that graph. For example of complete graphs, this is a key 4. So in this given graph, there are 4 different colors for 4 different vertices, and none of the colors are the same in the same graph. So according to the definition of the chromatic number in complete graphs, a chromatic number is the number of vertices. So since this graph has a 4 vertices, so the chromatic number also is equal to 4. Another example of complete graphs. So this is a complete graph or key 5. So in the given graph, there are 5 different colors, 1, 2, 3, 4, 5, for 5 different vertices, and none of the colors are the same in the same graph. So according to the definition that a chromatic is the number of vertices, since the graph has 5 number of vertices with different 5 colors, so the chromatic number is equal to 5. Let's come now to the bipartite graphs. A graph will be known as a bipartite graph if it contains 2 sets of vertices from group E and group B. So the vertex of A can only join with the vertices of B. That means the edges cannot join the vertices with a set. So it means that kung sa group E siya sa set A, dili siya pwede makakonect dito sa set irasab. So, ang set A dapat makonect siya sa set B. So, considering the properties in determining the chromatic number for these bipartite graphs, in any bipartite graph, the chromatic number is always equal to 2. For example, for bipartite graphs. So, considering this graph, this is set E and this is set B. So in the given graph, there are 2 different sets of vertices in the said graph. So matong ingon ako na mo ng set E, mo ang set B. So the chromatic of all bipartite graphs will always be 2. So kung unsa pa ni ka daghan diri na vertices like abot man 20 or 10, then 3 50 or 25. So the chromatic number will always be equal to 2. Okay, because nagbase man siya sa set sa group with each containing the different sets of vertices. So thus this graph has the chromatic number of 2. So 3 graphs. This is the last types in considering chromatic number. So a connected graph will be known as a tree if there are no circuits in that graph. In a tree, the chromatic number will equal to 2 no matter how many vertices are in the tree. Every bipartite graph is also a tree. So considering or following the properties in determining the chromatic number of this graph, in any tree, the chromatic number is equal to 2. Example of tree graphs. So this is Tree graph example 1, tree graph example 2. So for the first graph, in the given graph, there are two different colors for four vertices. So green and maroon. So 1, 2, 3, 4. Four vertices, but two colors only. A tree with any number of vertices must contain the chromatic number as two in the given tree. Second example, in the given graph, there are two different colors for five vertices. A tree with any number of vertices must contain the chromatic number as 2 in the same tree. So the chromatic number is equal to 2. For part 3, what is vertex and edge coloring of a graph? For the definition of a vertex coloring of a graph, a proper vertex coloring is an assignment of labels or colors to each vertex of a graph such that no edge connects two identically colored vertices. So, in vertex coloring, considering an example like there are two vertices, so ang edge nila, dapat ang katong edge, dili siya mo-connect og duha ka vertices na with the same color. So the most common type of vertex coloring seeks to minimize the number of colors for a given graph. So for the definition of a proper edge coloring, it is a function assigning a color to every edge such that if two edges share any vertices, the edges must have different colors. So kintahay sa, for example, one vertex tapos nag-connect og duha ka edge, dapat ang katong duha ka edge is dapat lalahi sila og colors. A proper key edge coloring is a proper edge coloring with key colors. A graph is key edge colorable if these exist. Example of vertex and edge coloring of a graph. So the first diagram is example of vertex coloring of a graph. So the first graph is a proper vertex coloring. So there are 1, 2, 3, 4, 5, 6. So 6 vertices, but you can see that there are only 4 colors. So 1, 2, 3. So in conclusion, there are 4 only colors. So we can call this graph as proper for coloring. And then the second example graph is not a proper coloring. Why? Because vertex A and B connected each other with one edge. So it means that E and B is an adjacent vertices. So it is not a proper coloring. So for the edge coloring of a graph, so this first example for the edge coloring, there are 6 vertices, 1, 2, 3, 4, 5, 6, and there are 8 edges. So this graph is an example of proper 5 edge coloring. Why? Because so 1, 2, 3, 4, 5. So since there are only 5 different colors, so this is a proper 5 edge coloring. For this second example, this is not a proper edge coloring because as you can see in this diagram, the black edges is connected each other. So from the definition of the edge coloring, dapat ang isa ka vertex must have a edges connecting to it na different colors. So for example, kanina vertex is connected with 3 edges. Since this is blue, so it satisfies the definition. Since and the second connecting edges and the third is both black, so does not satisfy to the definition. So this is not a proper edge coloring. For part 4, the application of graph coloring to real-life scenario. A territory is a connected mass of land. Considering this territory map of Dinagat Island, this island have 7 municipalities, namely Laredo, Tubajon, Libho, Basilisa, San Jose, Dinagat, and Caggianao. By now, we should be using abstracting relations into graphical form. We can make each municipality as a vertex joining with other neighboring municipalities. Then the edges would represent as the distance traveled by land of a person. Then coloring the vertices of the graph so that no two adjacent vertices receive the same color is equivalent to coloring the original map so that no two adjacent municipalities receive the same color. So considering this map, we need to put some dots in each municipality. So Loreto, Tubahon, Libho, Basilisa, San Jose, Dinagat, and Kajanao. So this kind of diagram, we need to connect the every vertex. The edges would be represented as the distance traveled by person by land. So from this, we can create a graph of that. So from Loreto, kintahay ang mga turista. If ang turista gikan sa Loreto, if gusto sila mo adto sa Picas Municipality, so sa Loreto, pwede ka makaagi by land sa next destination sa Tubahon. Then sa Tubahon, pwede ka moagi na sab ka duha ka dalan paingon sa Libho and Kajanao. So from Libho, pwede ka moagi padulong sa Basilisa and Kajanao. So from Basilisa is pwede ka moagi sa Libho, pwede ka moagi sa Kajanao, pwede ka moagi sa San Jose. So from San Jose, pwede sab ka moagi sa Basilisa, sa Kajanao, and sa Dinagat. So from Dinagat, pwede sab ka moagi sa Basilisa, padung po dito sa Kajanao. And then sa Kajanao is have the 5 routes para ang isa ka turista makaagi. So from Dinagat, San Jose, Basilisa, Libho, and Tubahon. So this is the graphical form na nabuhat na ko. So mauna ni siya ang final form or final graph ang nabuhat na ko base atong mapa. So the island map of Dinagat Island is an example of graphical representation in regards to graphical coloring. So we can say that it has a chromatic number of 7. Why 7? Because it consists different colors of 7 vertices. Since this is different from this to this to this and so on, so we can say that it has 7 chromatic number for 7 vertices. And each vertex is connected to every other vertex with different colors. So for that, in conclusion, we can say that this graph for the island map of Dinagat Island is an example to real life world. So that's the end of my discussion about graph coloring. So thank you everyone. Thank you for listening, and I hope na naman makuha na learnings from this lecture video. See you around. Bye.